Hello everyone, this is Mr. Ponte, and I'm not going to show my face today because we're in a different place. We're in my kitchen where I cook things. But today we're going to be combining different substances. Notice I got these cups from my medicine cabinet. They have all these measurements on them, and I think they actually work very well. I put a few lines at a few significant points, and I'm going to demonstrate what those lines mean and what they are. So we're going to go ahead and show you. Notice I got two cups together here. I also have a third one just to help me with measurement. And I'm going to demonstrate the procedure we're going to be using for the following. I also got this Sharpie here and a scale, which we're going to be reading. Okay, I also have a notepad here just to take notes. What we're going to be doing is combining substances together and looking at their mass and their volume as they're combined. Not so much the reaction as you usually do in a chemistry class, but what happens when you go ahead and put them together in terms of the mass and their volume. I'm going to be recording everything here, so just to demonstrate the procedure, I'm going to actually combine two things of water, obviously to expect. I'm going to actually fill them up to the first line that I made, this black line, and that's up to 10, it's marked up to 10 because I'm going to fill everything up to 10 milliliters in water. Or whatever substance I have. So this is cup 1, and this is cup 2. There we go. I'm going to go ahead and measure both of them here on my scale. Just note I have 10 and 10 here. Here's my scale. As you can see, I'm going to go ahead and switch on the light so you can see it a little better. As you can see, it's reading about 6, but I don't want it that, so I'm going to zero the scale once. Then I'm going to put my third cup on it just to help. I'm going to zero it again, so it's 0 to my cup, okay? So let's start up with cup 1 here. And you can see it's about 8 grams here. Okay, so that's the mass of cup 1. I'm going to also take cup 2. That's also about 8 grams. So I have two cups that are about the same thing. Obviously, they're the same substance. Let's see what happens when I combine them. Okay? And be sure all the water transfers from cup 1 to cup 2 here. Alright. I got one drop here that's just hanging out, so just give me a moment. Okay, there we go. As you can see, as you might expect, I get 16 grams of mass when they come together. Okay. And you see they fill up to this black line, which is kind of what I'm expecting here. Let me go ahead and twist the cup a bit so you can see it. Or let me rest it up here to the camera. See how they fill up to the black line here, and that represents 20 milliliters. Okay, so obviously the volumes did add up as expected, and also the mass. Let's go ahead and try out a few different substances and see what happens in each. For my next example, I have two substances that are kind of on the opposite end of each other. In cup 1, I have water, and in cup 2, I have oil. Now, you've already heard the saying, water and oil don't mix, but let's go ahead and see what happens when they do in terms of mass and their volume. Again, I fill them both up to 10 milliliters. Let's go ahead and take out our scale, and let's observe what happens when we combine these two substances. Okay, again, I'm going to, as always, zero my scale. Oops. I'm going to go ahead and zero my scale here, but I'm going to take this other cup I have. Be sure it's at the level. There we go. We'll start by measuring water. You can see water I got up to 9 grams. Okay, and 10 milliliters. Let's go ahead and check out oil. Oil I have up to 8 grams and 10 milliliters. So let's go ahead and see what happens when I combine the two. I'm I'm going to, as always, pour one into the other. Now, as you can see, just going to be sure the water gets in there. First of all, you notice several things have happened in terms of the water and the oil. You can see that, one is risen above the other. I have still, according to our line, 20 milliliters, as expected. And notice my mass, 8 plus 9 equals to 17. So, that's my next example. Let me go ahead and move on to the next one. For the following example, I'm going to go ahead and have cup 1 and cup 2 again, except this time, as you can see, two very distinct substances. I now have a solid and a liquid. This liquid, in case you're wondering, is not water. It's actually vinegar. It has that very strong, potent smell. And I filled them again, both to 10 milliliters. So now that I have that, I can go ahead and make my chart again. So I got water. I got vinegar, and I got baking soda. Okay, and I know both their volumes are going to be 10 and 10. However, we're going to go ahead and see what happens when we combine them. And also, we're going to go ahead and take a look at their masses. Note, I did actually make an addition to here, so I actually put this thing of plastic. It's actually going to affect my stuff by 1 gram, so we're going to go ahead and just weigh what goes here. And I just need this to seal off the reaction, because this makes actually a gas product that we will have to measure. Okay, let's start off with the vinegar. I'm going to zero my scale here. Okay, here we go. Here's vinegar. Vinegar, you can see, is much more dense than water. Actually actually has a mass of 10 grams going in. I'm actually going to remove this top for a little bit so we can get an accurate reading for the baking soda. And baking soda, you notice, has a mass of 7. Okay, this is going to be interesting. Okay, so I'm going to go ahead. I'm going to actually pour the water into the baking soda as compared to just kind of pouring it to another cup. I'm going to get this piece of foil. Well, let me go ahead and see how much this weighs. Yeah, it weighs about well, it doesn't weigh much. Shouldn't really affect my measurements. So we'll go ahead and let's see what happens. I'm going to put this right here. Now this might overflow. We're going to actually see what happens in real time here with the mass. So if you remember, I got 7 in one and 10 in the other. I'm expecting 17 in terms of mass. I'm going to have to quickly cover this up. So let's see. I'm going to pour cup 1 into cup 2 as we've done. Okay, and as I do that, oh. Well, as we can see, we've overflowed their container in a very rapid way. Let me see, I'm just going to seal it here. But you see, most of it got outside the container. But it is actually weighing about, 16? Yeah, so we got 16. We probably lost a lot into the air due to that rapid expansion. But we see we overfilled the container. And this container, as you can see, is about 30 milliliters. So we went way above that. I don't actually have a determination, but you can see the volume far exceeded that 20 I was expecting. I'm going to have to take some time to clean up the scale, so please give me a moment. For my last demonstration, I got 2 substances that are a little curious that you might actually find interesting when combined together. I have in one water, and in the other alcohol. So we're going to go ahead and see what happens when you combine these two. Just like all the other times, I filled them up to about 10 milliliters. And we're going to go ahead and see what happens as I mix the two. Alright, let's go ahead and actually first, though, weigh them. Again, as always, I'm going to go ahead and zero my scale. Here's my other cup. Zero the scale. So now it's 0. Let's go ahead and see water. As almost always, is about... let's see, it's about 8 grams. Okay. Let me see, do I have enough water in here? Yeah, I do. Okay, so I have about 8 grams of water in here. Okay. So, yes, okay, and let's check out the mass of alcohol. Alcohol is about 7 grams here. So 7 grams for alcohol, 8 grams for water. Let's go ahead and see what happens when I combine the two. Okay, notice I do have alcohol sealed because it does produce vapors. Number one, I don't want to smell them, but number two, I don't want them escaping. So here we go. I'm going to pour in the water into the alcohol. And unlike last time, I actually do have the chance to stir it a little bit. So that way I can go ahead and effectively mix the two. Okay. There we go. As I somewhat predicted, the volume of the mass of the two ends up to being 16. Okay. Because it was 8 and 8. What you may find curious, though, is when we go ahead and measure the volume. The volume actually is very interesting because, I don't know if you can see this, 20 is actually a little higher. It's actually up. If you go ahead and take a look, it's actually up here. And you notice my liquid level is, well, let me go ahead and remove my hand, right? 20 is right up here in terms of the scale. You see this line here? And you see my liquid is actually just a little less than that. Actually somewhere hovering around 18. So it's actually curious because this actually is an example of liquids not expanding when you go ahead and combine them, but shrinking. Okay, so we're going to go ahead and I'm going to allow you to examine these 3 examples. We'll go ahead and talk about each, and we'll go ahead and maybe try to find an explanation. Alright guys, good luck. I'll see you guys later.